Okay, good evening, everyone. Okay, good evening, everyone.
Good evening, sir.
Okay, sir, start.
I think we should start, but there are few people, only 7 people are there. So
कोई
I think
बात
we
नहीं
should
सर,
wait.
बताते रहेंगे लोग। ऑनलाइन
शुरू
में ये
कर
रहता
शुरू कर दें.
है।
ओके, ठीक. So we should start. Dear participants,
आवाज आवाज बहुत स्लो आ रही है आपकी आवाज।
मेरी.
यस यस।
ओके, अब सही है. हेलो.
नहीं नहीं नहीं, बहुत धीमी है सर।
हेलो.
हाँ, बहुत धीमी आवाज है सर।
कैसे बढ़ाएं? ये तो मैंने 100% कर दिया. हेलो.
हाँ सर, आवाज बहुत सही धीमी आ रही है सर आपकी। नहीं नहीं, हो सकता वो हो।
Participants, please tell me whether my
सर
voice
ठीक
is.
आ रही है बात सर। सर ठीक आ रही है, कोई इशू
ओके
नहीं है।
ओके ओके. ठीक है. सो आई थिंक वी शुड स्टार्ट. कल आपको समझ में आया था. हेलो. हेलो.
यस यस सर, कंटिन्यू सर।
Okay, okay, okay. So today we will start from the data extraction operators. Okay. In R, we can extract data from vectors. We can extract data from matrices and list also. There are many more things. So first we have this in square bracket. Square bracket से आपको open करना है and then you have to close by square bracket, and this may select a value, a single value, a vector, or even a matrix. Depends on from where we are extracting the value. And second one is used for dollar. So normally dollar is used to extract a vector from data set. Just suppose yesterday we have discussed a data frame, and that data frame contains 2 or 3 variables. So if we want to select one of the variables from that data frame, we may use this operator, mean dollar operator. See how R is very rich in database. If we go in R and just write data and then brackets. So if we write this and just enter, simply enter, we have the names of the data sets. All the explanations about the data sets are available here. See here we have a huge number of data sets. They are in R base. So we may use any of them. So here I think we will be using data sets about chick weights. This one chick weight, and there is one more. There are two data. So we will be using these two. Where is this chick weight? Just check this. Simply write, to read the data from this, write data and then double quotes. Within double quotes, write the name of the data set. So we have written data, then double quotes, and within double quote we have written the name of this, and then we enter. So that's mean this data is available. If there is no error, so that's mean this data is available. Just suppose if we write capital C instead of small c, again the same things, and we run. See here we are getting the problem. In data this data set chick weights not found. Okay, so if commands run, there is no error, no warning message, then that's mean it is okay. So we read chick weights data from R base and we run this. Okay, then we want to see that how many variables, since this is unknown to us, so we want to know that how many variables are in this data set. So we use function names. Names gives us the name of the variables. So names chick weights, see here it is giving us two, weight and feed. सो डिफरेंट फीड्स पे वेट्स को मेजर किया गया है कि चिकन्स का वेट कितना गेन हो रहा है, किस तरह से वर्क कर रहा है. दिस इज मेजर्ड ऑन द बेसिस ऑफ फीड्स. सो वी चेक, सर फर्स्ट वी रीड chick weights, dollar weights. So what it gives? It gives us the values of all. So there are 71 observations and all of them are here. Okay, now we want to read only one observations from this weight. So first we use this dollar extraction to read a vector, to read a variable from the data set, and dollars operator is used. Later in this one we are using a square bracket to read the first element of this, and then we run this. Now we print weight 1. So weight 1 is equal to 179, right? And see here, this is the first observation of this weight, and this is also 179. Just suppose you want to change this. Instead of 1, we write fifth one. We need fifth one. So we just run and see this is 217. So now we will see that whether the fifth observation is 217 or not. First, second, third, fourth, and fifth. Fifth is 217. Okay. Now here we are reading first 10 observations from this weight, and this is read. This is extracted. Now again print this, and after printing we have seen here that first 10 observations of the weights are printed here. Okay, clear? One more thing, there is a function name subset is also available. Why we are using this function? Because here our feed, just we want to see about the feeds, chick weights dollar feed. Okay, now we run this. So we see this, mean this feed is a categorical variable. Categorical variable, we are giving them first horse bean, then linseed, then soybean, then sunflower, then meat meal. So we are giving the chickens these meals and checking their growth. So there are 6 variables and all of them are factors. So we have used, or we have also extracted the data on the basis of these factored variables. Just suppose we want that if we have feed them soybean and what is their weights. So for that we have obtained this one, mean the function is subset and then data frame name, and then we have to set the condition on what basis we want to select the values. So we have set it here, feed is equal to soybean. Okay. So see here, sorry, feed is not available. Okay. Then we print this data, soybean, and we have see from 23 to 36, these observations in our data set check weights is stored for soybean feed. Okay, we may change this. Just suppose we want linseed or meat meal, suppose wheat meal. Meat meal is equal to subset, then the data set name check weights, then comma, and we give the conditions for what we are going to select the values. So right here, meat meal. Okay, there is one thing that is important, that if you are writing anything except from the commands, so you have to give them in quotes. अगर कोई argument है then okay, if you are giving any names that is that name is categorical, then we have to write them in quotes, and then we run this and then again print this. We see that from 49 to 59, these observations stored in chickweight's data set, and they are stored for, mean the weights are for meat meal. Okay, so there are three methods we have used to extract the data from data set. One is square bracket, second is dollar, and third one is subset. Okay, then descriptive statistics, we can use mean, median, mode, anything. We can use also like calculator. Just suppose if we want to calculate the mean of 28735, if we want to calculate these observations, mean of these observations, so there is one method, mean like we write 1, no sorry, 2 plus 8 plus 7 plus 3 plus 5, and we see this is a number 25, right? So we are writing them. Instead we will use a function sum, and then we write all these values with c. आपने इसको एक वेक्टर बनाना है c, and then we run this command and the value is again 25. Both of them are resulting the same thing. Okay, so similarly we have a function mean which gives us the mean of these 5 observations, and the mean is 5. Why? Because the sum of these 5 elements is 25 and we have total number of observations, that is 5. So sum divided by the total number of observation is called mean or average. So because of this we see this is 5. Here we have calculated manually S1, that is sum of the weight. Mean we are taking the weight of whole information, means 71 information जो यहाँ से आ रहा ना weight, this one, see this highlighted part, ये जो हमने यहाँ पे weight किया हुआ है इसका हम mean calculate करने जा रहे हैं. So now we take the sum of weight and this is stored in S1, and then we give a new name to the number of observations available in this weight and run this. The function for that is length. Length of weight mean total number of observation in weight. Then we calculate x bar. X bar is equal to, mean this is traditional formula, mathematical formula, sum over total number of observations, and we run this and then we print this x bar, and this x bar is saying that our average weight of the chickens is 261.3099. Okay, now we will use mean function to calculate this. So we write mean and then weight. See, both of them are similar. Okay, because we are obtaining the mean of same data set with two different methods. In one we are calculating manually. First we are taking the sum, then we are dividing by total number of observations, and we are getting this. And in second one, we are using a function mean that is inbuilt in R. For median, the function is median of this. Okay, so it is easy. It is too easy to calculate mean. The function is mean. To calculate median, the function is median. But the function of mod, mean if you want to calculate the mod, the function of mod is not available. Okay, so we cannot calculate directly mod here. There are some adjustments, so that's why we are not discussing this. Mean and median, both of them are easy and can be calculated easily. The variance of this weight can also be calculated by the simple function where and then weight. So variance is the where, sorry, मैंने सिर्फ हाईलाइटेड पार्ट रन कर दिया. अगर आपने हाईलाइट कर दिया जितने पार्ट को, सिर्फ वही पार्ट रन होता है. So where weight is 6095.503, and standard deviation of weight, standard deviation is the square root of variance. Okay, this is the square root of the variance, and when we have taken the standard deviation of this, so this is 78.0737. So whenever we have data, we need its mean, median, variance, standard deviation, quantiles. These things are needed. Then further we can plot this to check the normality of the data. From plot we can check these things. One more thing can also be observed from here. See, this is our whole data set. This is scattered. The minimum value is around this. नजर आ रहा है? And this yellow line is the mean of this. So we can see the scatteredness of the data. On x-axis we have number of observations or number of chickens. On y-axis the weight is displayed, and the points, these points are the data points, and this yellow line is the mean. So we can see the scatteredness of our data. Since the data is scattered, mean data एक जगह mean के around बिल्कुल fixed नहीं है. That's why we have seen our standard deviation or our variance was high. Our variance is 6095. Why? Because these data were scattered too much. अगर वो बहुत close हो जाए, if the data are close to mean, then this is small. Now we will see quantiles. Quantiles gives us the first quantile or first quartile. First quartile mean 25% data is below this and 75% data is above this. So this gives us four things. First is 0. So that's mean from here the value starts, that is 108. And then first quartile, that is 25%. 25% mean 108 to 204. इस बीच में इसकी 25% ऑब्जर्वेशंस हैं. Then 204 to 250, 58 इस बीच में further 25% है. If we consider from 0, then this is 50%, and if we consider from 25%, then this is 25%. It depends that from where we are talking or we are looking. यहाँ से यहाँ तक 25% हो गया, and now from 25% to 50%, it is also 25%. So there is a difference of 25, 25 and 25. Okay. So first quartile, second quartile, this is median to median, and this both the values are same. 50% mean second quartile or median, both of them are same. Then third quartile, and then 100%. So quantile gives us these values, result these values, and then there is one more function summary that includes these four too with some other things. See, minimum, first quartile, median, mean. One more function is here, mean. Mean is also involved in this function. And then third quartile, and then max. You can compare the both. You can compare the both of them are giving us the same result, only mean is additional in this summary function. Then we can visualize our data set by histogram. To make a histogram, the function is hist, hist, and this is giving us this result. Okay. So from here we can see that what is our data mean, the type of our data looks like, whether this is normal or not. So from here it is not easy for us to say that our data is normal or not. So we will later see and will perform a test to check that whether this data is normal or not. But if we see, then whether there is any possible curve or not, possible normal curve or not. So if we have also added the density function on this, and this density function is showing that this might be normal, this is close to normal, not exactly normal, but this is close to normal. Okay, so we will check the normality test later, and then we do stem and leaf plot. Where is this? This plot is there. This plot is also same, mean this gives also the same result as histogram, but histogram is vertical and this one is horizontal. And if this is also following normal distribution, so this mean upper part, ये जो हिस्सा है, ये हिस्सा, this should be like normal curve, bell shaped curve. Okay, then box plot is also plotted, and box plot is also used for the same things. It includes outlier. We have seen there was error. Why? Because this window, this window was small, that's why there was error. Now we will again run, and now we see there is no error. Okay, so this gives us, this is actually called 5-number summary. 5-number summary mean minimum, first quartile, second quartile, third quartile, maximum, and then outliers. यहाँ पे चूंकि आउटलायर्स नहीं है इसलिए आउटलायर्स हमें शो नहीं हो रहे हैं, but right now I will use another data to check the outlier. Okay, so see this one, this is called the minimum value. This called the first quartile, mean lower line of the box is called the first quartile. This darkest line which is inside the box is called the median, and then the upper line of the box is called third quartile, and then this one mean the line which is added by mistake. ठीक है, whisker, this is not the name of this is whisker. Okay, so this is maximum. So if we see that this line mean this dark black line is exactly in between the 2 points, mean third quartile and first quartile, then our data is normal. But here we see that there is slightly difference between the two. So that means it is not exactly normal, it is not perfectly normal, but it is close to normal, what we have seen from the other graph. And one more thing that is used to check the normality, that is called QQ norm. Okay, so first we run QQ norm. These are the points of our data sets, and then we add a line, and if all these data sets are lying on this line, then we say that our data set is normal. Here we see that there is deviations in the beginning and in the last of this line, so that means they are not exactly normal, but they are close to normal. Okay, all these data say the same things. Let me show you about box whisker in how it is showing outliers. Chicken weight, this is another data set, and from here we weight chicken is equal to chicken weight dollar weight. Okay, and then we use box plot. of this weight CH. Okay, run this. Now see this one. Here, this is the minimum value. Mean lowest line of this is the minimum value. Then the box lowest line is the first quartile. Then darkest line which is inside the box, this is the median. And this upper line of the box is called third quartile. And the line which is attached with this box by dotted line, this dotted line is called mustache or whisker of a cat. And there are some points which are above this line. They are called outliers. The lines which are above this maximum value is called outlier. So कभी maximum पे मिलेंगे, कभी आपको minimum पे मिलेंगे. In this data set we have above the maximum. So we have outliers in this observation, in this data set. Okay. Now come to the main things that is important for us, and that is hypothesis testing. So hypothesis testing. First thing, what is hypothesis? Hypothesis means any claim or a statement made about any population or any particular things is called hypothesis. And if we are using some procedure, some statistical procedure, so it is called statistical hypothesis testing. Okay. For example, if we say that the boys and girls group, if we are comparing the students on the basis of gender, so we say there are two genders, male and female. Now we check the performance of this. So we may make a statement that girls students are outperforming the boys, or we may make an other statement that boy students, male students are outperforming the female students. Okay. Second statement may be a teacher. I have given a teacher assumes that 60% of his college students comes from lower middle class family. Or another statement may be the performance in NEET exam, the performance of girls was better than the performance of boys. ETC, इस तरह के बहुत सारे statements हो सकते हैं. We can have a lot of hypotheses. But we further divide this hypothesis into two parts. One is null hypothesis and another is alternate hypothesis. Null mean this is unbiased, purely unbiased. We are not taking anyone's side. We are just being natural thing. Just suppose if we say that female students are outperforming male students. So when we make null hypothesis, we say that no, both of the students' performance is equal. The performance of both the groups is equal. So हमें किसी के साइड नहीं जाना. We have to be natural. We have to be unbiased. Okay. Second thing, just suppose if a new medicine made by any pharmaceutical companies claim that my medicine is better than the previously existing methods. So when we are going to test them, we say that this new medicine is exactly same as the previously existing medicines. I mean, there is no difference between the two. Then we make alternative on the basis of claim. Then we have to check what was their claim. So we say that they are saying that the new developed medicine is better than the previously existing medicines. So that's mean here we are saying that one is greater than the other. So our interest is in new medicine. So we say that mu1, just suppose if we calculate the average performance of medicine 1, so this is called mu1 or new medicine, and the other previously existing medicines were denoted by mu2. So we say mu1 is greater than mu2. Okay. So I have stated some examples here. So if we write first condition that mu1 is greater than mu2, then this is called right tail test. Why? Because we are moving right to the mu2. आप अगर आप real line बनाएं, just make a real line and we see what it is saying. Mu1 is greater than mu2. So first we will make mu2 on a line, and then we see that we are going mu to mu1, and this is in right direction, right hand direction. Okay. Second, we make mu1 is less than mu2. This is called left tail test. Again the same story, just make a real line, point mu2 on real line, and then we are saying mu1 is less than mu2. So when we are saying mu1 is less than mu2, so we are going left hand side. So that's why this is left tail. And in another one, we are saying that we are not sure that which of the two medicine is performing better. So when we are not sure, then we say mu1 is not equal to mu2, and this is two-tail test. Okay. So there is one-tailed and one is two-tailed. For example, we have considered two methods, two examples. A new teaching method is developed that is believed to be better than the current one. Then for this statement, we set a null hypothesis, that is saying that the new developed method is same as the old one or no better than the existing one. As I have given you as I have given you the example of the medicine, this is also saying the same thing. When we are saying that the new teaching method and the old teaching method, both of them are same, mean one is no better than the other one. The same thing is for sales also. Then type 1 and type 2 error. This is important thing. Type 1 error mean we are rejecting the null hypothesis when it is true. Mean we are saying that the two teaching methods are same. Alternatively, they are not same, or what new is better than the previous one, or new is worse than the previous one. So आपके पास conditions हैं, you may set them, and we are saying if we are wrongly rejecting the null hypothesis when it is true, maybe we may be biased. So it depends on the situation कि हम किसका टेस्ट कर रहे हैं. ठीक है. So if we are biased, then we are getting a serious problem, and that problem is called type 1 error. Mean we are rejecting a good thing. Second is type 2 error. Type 2 error says that fail to reject the null hypothesis when it is false. Okay. And then the probability of these two are taken, and they are called level of significance and power of test. Here it is example is given to demonstrate this error. So see, if there is a trial in a court that a man has committed the crime or not, then the following table is the best example to show the types of errors. So for this, we set the null hypothesis that the man is innocent. It is said that it is in law that until proven one is innocent. तो जब तक ये प्रूव नहीं हो जाता कि आपने कुछ गलत किया है, तब तक आप innocent हैं before the law. And alternative is saying that this man has committed crime. So the alternative is saying the man is guilty. Now we have four options. First is, see this column name, the man is innocent. The man is innocent means H naught is true. And second column is saying that the man is guilty. That means H1 is true. Okay. Now row names are showing the decisions. So decision in favor of the man mean अगर man के favor में decision आ गया तो क्या होगा? If the man was innocent, mean H naught was true and the decision came in favor of him. So first, see the first element of this matrix, that is no error. If man was innocent and decision came in favor of, so that's mean there is no mistake. But if the man was guilty and decision came in favor, mean he has acquitted, वो गिल्टी होते हुए भी छूट गया, उसको पनिशमेंट नहीं हुई, then this is a error, and this error is called type 2 error. Okay. And if we say if the man is innocent and decision came against the man, So this is considered a very serious thing, because here we are going to punish a man who was innocent. So here in law, an innocent man must not be punished even if a guilty can be acquitted. And then the man was guilty and decision came against the man. So again there is no error, mean he is punished. So यहाँ पे कोई issue है? Any of you
No, sir.
understood? Okay. So see, there are three graphs made on the basis of null and alternative hypothesis. See, we have written mu1 is less than mu2. H0, H1, when we have said here, this one, middle one. जो second one left tailed है ना, for left tailed, ये जो second one यहाँ पे नजर आ रहा, for left tailed we have made this graph. मीन ये जो ब्लू रीजन है, दिस ब्लू रीजन इज एक्सेप्टेंस रीजन एंड दिस shaded region mean this is not red actually, but this is look like red. So this is mean rejection region. So if our value lies here, so this is false. So that's mean we reject the null hypothesis. And if our value of the statistics lie in this blue region, then we accept the null hypothesis. The same thing for the second one. Second one is right tailed, and for right tailed we do again the same thing. If our value of test statistics lies in this, see the range of this is from -3 to +3. -2 to 2 नजर आ रहा है आपको ये on x axis, -2 0 then 2, then उसके बाद 1 है, so this is 3 and here it is -3 to +3. So इसके बीच में जहां कहीं भी वैल्यू लाई करेगी, we are going to reject. And on in two tailed, see the shaded region on both side, the red region on both side. So that's mean here we may get the value on both side. It may be on left side, it may be on right side, we may get value on both side. So if our value, just see here, the shaded region in almost, see closely, the shaded region in almost everyone starts from 2 or from -2. So if we take absolute value of 2, so it starts from 2 to 2. Okay. So that's mean this is thumb rule, not in general. This is thumb rule. If our value is greater than 2, in general, you may see that if our calculated value is greater than 2, then we reject the null hypothesis. But nowadays, we stick to p value, right? We see p value. So if our p value is less than 0.05, if our p value is less than 0.05, then we reject the null hypothesis. Otherwise, we fail to reject the null hypothesis. So first we will use normality test, right? And to check the normality of a variable, we set the null hypothesis at the data vector is normal. And alternative, the data vector is not normal. So now to them, I will run the code so that you could better understand these things. Okay. So here we have taken a data set, and that data set is energy taken by 11 women. So ये उनकी जो energy taken है उसका data है. Now we run this vector. So now this vector, okay, 1 minute. There is some issue, I think. मेरी इस फाइल में कुछ मसला हो गया है. So instead I will use this file. Okay, so we run this daily intake. So energy taken by women's is run, mean there is no error. See here, there is no error. So that's mean it is run. And then we use Shapiro-Wilk test. So Shapiro-Wilk test reveal result, and we see what? The Shapiro-Wilk normality test, the test statistics, this is the test statistics, and this is saying 0.95237. It is the value of the test statistics, and we see the p-value. We see that p-value is 0.6743. So we see if this value is greater than 0.05 or not. So see written here, since the p-value is greater than 0.05, therefore we fail to reject the null hypothesis. And what is the meaning of this? When we fail to reject the null hypothesis, that's mean our data set is following normal distribution. Is that clear? Any issue?
No, sir.
No, okay. See, then again we will test here Shapiro dot test, and we have two data set. Weight. This weight was taken earlier, and we check run this command. This. So we see that Shapiro-Wilk normality test data is weight, and then W mean Wilk test mean the value of this is 0.97674, and p value is again greater than 0.05. So when the p value is greater than 0.05, so that's mean the test statistic is significant. And when we say that the test statistics is significant, then we mean that the null hypothesis is accepted or failed to reject. So in our case, we fail to reject the null hypothesis, and that's when our weight data is normal. We have read one more weight data, and that was CH, weight CH. This was taken from different sample, and we test this one, in which we have seen there was outliers. जिसमें outliers मिले थे, हम उस डेटा का अब नॉर्मलिटी टेस्ट कर रहे हैं. ठीक है. पहले वाले डेटा में इससे जो बॉक्स प्लॉट बनाया था, इससे हमें आउटलायर्स नहीं मिले थे. हमने जब इस डेटा से बनाया तो इससे हमें आउटलायर्स मिले थे सेकंड डेटा से. याद है ना बॉक्स प्लॉट में? So now we have tested this Shapiro-Wilk normality test, and data is equal to this, W is equal to this, and see the p value. P value is 2 into 2, sorry, 2.2 into 10 to the power minus 16. 2.2 into 10 to the power minus 16. What is the meaning of this? Anybody understand this? Yes, no? No, I think. Okay, so I'm showing what is this. The meaning of this is equal to this. Mean there are 15 0 before 2 after decimal. The value is too small. The probability is too small. It is close to 0. The probability can never be 0. Okay, but it is too small. So that's mean this value is highly significant. And when we say that this value is highly significant, so that's mean we reject the null hypothesis. And for Shapiro-Wilk test, what is our null hypothesis? Anybody? For Shapiro-Wilk test, what was our null hypothesis? No. Our null hypothesis was, see here, that data is normal. See these two. The data vector is normal. Our null hypothesis, and alternative HA or H1, the data vector is not normal. So when we are testing this and we are getting p-value of this, so that's mean we are rejecting the null hypothesis. So when we are rejecting the null hypothesis, that mean we are saying that our data is not normal. So one data was normal, one weight data was normal, and second weight data is not normal. Okay. Then we test homogeneity of variance. We are testing these things because whenever we are using parametric test mean t-test, f-test, chi-square test, when ANOVA test, when we are using these tests, we need to check two assumptions. First, that the sample is coming from the normal population, and second, whether the groups, if there are more than two groups, so whether the groups mean 2 3 4 groups, they are having equal variance or not. If the variances are equal, then test is different. If the variances are not equal, then the test is different. So we have to check these things. Okay, so here we have calculated the variances of both the groups. See, f0 is equal to sigma 1 square is equal to sigma 2 square. So mean variance of the first group divided by variance of the second group. And we say that the null and alternative hypothesis is also shown here. See, check this. The variances of both groups are same. Alternative, the variances of both groups are not same. Then we have taken two observations. One is heights of male and second is heights of female. So first run these data sets, and the function for this is where.test. The function for this is where.test, and simply give both the variables, female's height and male's height of male and height of female, and run the command. See, f test, the outcome says f test to compare two variances. Then data, height of female and height of male. F value is there. So F value is 1.1559 with degree of freedom 9 and 9. And P value is 0.8327. This is important. The P value is 0.8327. So when we have this value, so that's mean our test is insignificant. When our test is insignificant, so that's mean we fail to reject the null hypothesis. We fail to reject the null hypothesis. So when we fail to reject the null hypothesis, that's when the variances of both the groups, heights of male and heights of female, are similar. They are same. I think it is clear.
Yes, sir.
After this, we will use t-test for one sample. And t-test for one sample, the function is t-test. See here. So t.test, the function is t.test. Then first argument is x. Second argument is y, and that is optional. If we are talking for one sample, then y will be absent. Then we have alternative. This alternative is taken from the alternative hypothesis. It should be clear in your mind whether your hypothesis test is less than type, greater than type, or two-sided. So for two-sided, it is two-dot-sided. And then mu is equal to 0. This is used, if we say, what we have said? We have said that, I think, the diabetes of Indian people is around 15%. So here mu will be 15, right? And paired is equal to false or true. टी टेस्ट में एक कंडीशन पेयर्ड की भी होती है जब हम टू सैंपल की बात कर रहे होते हैं. प्री एंड पोस्ट, बिफोर एंड आफ्टर की जो कंडीशन होती है उसको हम पेयर टेस्ट बोलते हैं. एंड सी हियर, अभी हमने वेरिएंस को चेक किया था, वेल डॉट इक्वल इज इक्वल टू फॉल्स और ट्रू. इसको आपको सप्लाई करना पड़ेगा. जैसे अभी हमने इस केस में मेल हाइट और मेल फीमेल हाइट दोनों में चेक किया था. देन वी हैव सीन दैट the p value was too high, it was around 0.83, so that's mean the variances were equal. So यहाँ पे where dot is equal to true लिखना पड़ेगा, false नहीं लिखना पड़ेगा. ठीक है. And then confidence dot level is equal to 0.95. So 9, we are always calculating this at 0.95%, so it is okay. By default it is 0.95. Okay, so we have considered a data. This data set is taken from this data set is of blood pressure from hypertension patients. Okay, and there are 12 patients whose blood pressures was recorded. Now we are going to say that from which population this data is taken. So the mean of that population's blood pressure is 165 or not. अब मैं ये चेक करना है कि जिस भी पॉपुलेशन से ये डेटा सेट लिया गया है, क्या उस पॉपुलेशन का एवरेज ब्लड प्रेशर 165 है या ज्यादा है. So see the word, can we conclude on the basis of these data that the population is less than. So population is less than mean alternative हमारा होगा H1 HA होगा that mu is less than, okay, 165. So see here we have stated the null and alternative hypothesis. So we say mu is equal to 165. Okay, mu is equal to 165, and then alternative mu is less than 165. So यहां पे आपने एक चीज देखा, जो अल्टरनेटिव था, अल्टरनेटिव में हमारा क्या आ जाएगा, लेस. अल्टरनेटिव में क्या आ गया, लेस. नाउ वी use t test. So first we have defined a data vector systolic bp, mean we have given the name of this data set as systolic bp, and we run this, and then we use normality test, means Shapiro-Wilk test, to check the normality, and we see that the p value is 0.531. So when the p value is 0.531, so that's mean our data is normal. Okay, when our value is greater than 0.05, so we reject the null hypothesis. When we reject the null hypothesis, sorry, I again make mistake. When our p value is greater than 0.05, so we fail to reject the null hypothesis. So when we fail to reject the null hypothesis, that's mean our data is normal. Okay, and then we run this test. T dot test is the function, and then vector, and then mu is equal to 165. Y is not present here because it is one sample test, and then we say alternative is equal to less, and here paired, since there is only one sample, so there is no chance of being paired. Okay, so we run this. The t value is minus 1.053. Degree of freedom of this is 11, and p value is 0.1575. So when we say that the p value is 0.1575, so that's mean our test is insignificant. When we say that our test is insignificant, so that's mean we fail to reject the null hypothesis. So that's mean from where this sample, from the population where this sample is taken, the average of the blood pressure of that population is not less than 165. It is 165 or more than 165. Is that clear? Here, because we are accepting the null hypothesis, and our null hypothesis is 165. Check again this one. Null hypothesis is h naught mu is equal to 165, and alternative is saying that mu is less than 165. So we fail to reject null hypothesis. That's mean we are accepting the null hypothesis. So we say that the population from which this sample is taken, the average blood pressure of that population is 165. It is not less than 165. I think this is clear.
Yes, sir.
Okay. Another example is taken from the intraocular pressure. This pressure is I think eyes pressure, eye के अंदर कुछ होता है, and 21 observations are there, right? See, 21 observations are there. Then we have what we have to check. Can we conclude from these data that the mean of the population from which the sample was drawn is greater than 14? Is greater than 14. Earlier case was less than. This case is greater than. So now we set null hypothesis mu is equal to 14. See, mu is equal to 14 and alternative is mu is greater than 14. Okay, mu is greater than 14 because it is written there that intraocular pressure of the population is greater than 14. So under the null hypothesis, we have to test or we have to check whether the intraocular pressure of this population is greater than 14 or 14 only. So first we have make a vector of this in intraocular pressure, and then we test the normality. We use Shapiro dot test to use the normal to check the normality. So again the value is 0.5941. So this value is again greater than 0.05. So when this value is greater than 0.05, so that's mean our test is not significant. When our test is not significant, then we fail to reject the null hypothesis. And when we fail to reject the null hypothesis, so null hypothesis says that the data is normal. So here we conclude that our data is normal from this Shapiro dot test. Okay. Then we use t-test, and the function for this t-test is t dot test and then vector intraocular pressure, and then mu is equal to 14 that was given in question, and alternative C is greater than, this is taken from the alternative hypothesis. Okay, and then we run the test. After running the test, we see that data name is there, t value mean test statistics value is there, degree of freedom, df mean degree of freedom, and then p value. See here, the p value is 0.01988. This value is less than 0.05. So when the value p value is less than 0.05, so that's mean our test is significant. And when our test is significant, so we reject the null hypothesis. When we reject the null hypothesis, so that's mean the intraocular pressure of this data or the population is greater than 40. Okay. So this was all about the one sample test. I've discussed two examples. If you have any problem, then please note it down and ask me later. And then we will discuss about the two independent samples. And when we have two independent samples, so we have two groups. So when we have two groups, so we have to check again two things. One is normality of the vectors, normality of the two vectors, and second, whether the variances of two groups are equal or not. So again, we check on the height of male and female. We have discussed it earlier. So height of male and female, and we checked that time that the variances of these two groups were equal. So we said where dot test. I think we did it, but we should again do height female dollar heights male, and then run this. We see p value is greater than 0.8327. So that's mean the variances of two groups are equal. And then check out the argument of this. T dot test is the function, and then first variable, this is our x, first variable's name, then comma y, This is second variable, okay, or second vector. And then we are writing var dot is equal to true. Var dot is equal to true we are writing because we have already checked whether the variances of the two groups are equal or not. Okay. Then we are writing alternative is equal to two-sided. Why we are writing this? Because we are not sure whether heights of the male or female whose height is more than. So we are not sure about this. If we say that male's height are greater than female's height, then we have greater sign. And if we say that male's height is less than female's height, then we have less sign. सो डिपेंड्स ऑन कि आप क्या नल और अल्टरनेटिव हाइपोथेसिस सेट करते हो, उसके हिसाब से यहाँ पे आप ये इस अल्टरनेटिव को सेट करोगे. एंड देन वी रन दिस कमांड. व्हेन वी रन दिस कमांड we see that the p value is this. The p value is 0.001426. So on the basis of this value, please tell me whether we have to reject or accept the null hypothesis and what will be our conclusion. Anyone from
P
the
is less than 0.05 actually.
Yes, it is less than 0.05. Then what is the conclusion?
So we should reject the null hypothesis maybe.
We should reject the null hypothesis. So what is the meaning of this? If we want to explain in terms of female height and male height, then how to say that?
That means the mean is not equal.
Yes. The mean the average height of male and average height of female is not equal. Okay. The average height of male and average height of female is not equal. Okay. Then we have another example or another test that is for variance when variances are unequal. Okay. When variances are unequal. So we set the null hypothesis and alternative hypothesis same as we have done here. We have two groups. So see, mu1 is equal to mu2. This is our null hypothesis. Alternative may depend on whether mu1 is greater than mu2. So this is greater. Mu1 is less than mu2. This is less. And mu1 is not equal to mu2. This is two-sided, two dot sided. Okay. ये यहाँ alternative से आता है. And then we have basically we have generated numbers to show that how can we generate the data. So we have obtained this data set from normal distribution. So normal distributions say first this is the function to generate the function 20 observations. So n is equal to 20, mean 20 observations are generated from this normal distribution, and the mean of these 20 observation is 2.00001. Okay, and the standard error is 1. Standard error is 1. Same, another variable y is also generated from the normal distribution. The function is r now. 25 observations are generated and the mean of this is 2.0002, and the standard deviation of this is 2. So obviously the variances of the two groups are not equal. Standard deviation is 2. The variance of this becomes 4. Okay. So we run before going at set.c, then we use var.test. इस टेस्ट को यूज करते हैं to check that whether the variances of the two are equal or not. So we run this command. F test is this, mean F test to compare two variances, degree of freedom data y and x, and the F value is 3.155. Numerators degree of freedom, this is num mean, numerators degree of freedom is 24 and denominators degree of freedom is 19, and p value is 0.01351. So this value is less than or greater than 0.05.
Again, this is less than 0.05. That means ratio of variance is not equal.
Yes, ratio of variances is not equal to 1. Okay. So that's mean variances are not equal. So we may use t-test when the variances are not equal. So all the things are same. T dot test x comma y dot is equal, and we may also add alternative c and then write 2 dot sided and then run this. Again, check out this one. What is the p value? P value is
Greater than
0.6246. So that is greater than 0.05, right? That is greater than 0.05. So we fail to reject the null hypothesis or we reject the null hypothesis.
reject
Reject what?
null
Null
hypothesis.
hypothesis. No, you are mistaken. P value is greater than 0.05. So when our p value is greater than 0.05, then we fail to reject the null hypothesis. I will show you this one. See this graph. मैंने बोला था इसमें जो ब्लूइश है एरिया, दिस एरिया इज लार्ज, राइट? और अगर लार्ज एरिया में लाई करेगा सो वी हैव टू एक्सेप्ट, मीन वी फेल टू रिजेक्ट. और इस रेड रीजन में लाई करेगा देन वी हैव टू रिजेक्ट. सेम इसके लिए भी है. फॉर ब्लू रीजन वी फेल टू रिजेक्ट और वी एक्सेप्ट, और इस रेड रीजन में आएगा देन वी हैव टू रिजेक्ट. यहां पे अगेन इन दोनों रीजन में होगा देन वी रिजेक्ट द नल हाइपोथेसिस, और इस ब्लूइश एरिया में आएगा सो दैट्स मीन वी फेल टू रिजेक्ट और एक्सेप्ट द नल हाइपोथेसिस. सो जैसे ये जो एरिया है, दिस एरिया इज टेलिंग अस अबाउट द प्रोबेबिलिटी ऑफ 0.05. दिस इज प्रोबेबिलिटी ऑफ 0.05 बिकॉज दिस इज स्मॉल, राइट? दिस इज 0.05. ये दोनों मिल करके होगा, तो बेसिकली दिस इज 0.02, 0.025, 0.025. Okay, so since the value is greater than 0.005, so therefore we fail to reject the null hypothesis. And when we fail to reject the null hypothesis, that's mean the means of the two variables are not different. ये conclude किया हमने ना, the means of the two groups are not equal. ये equal होगा?
नहीं होगा, ये तो हमने पहले किया ना.
नहीं, इसका इक्वल होगा.
अच्छा, just because it is more than 0.05.
Yes, it is greater than 0.05. So the mean of the two groups will be same. Null hypothesis तो ये है ना, mu1 is equal to mu2.
Yes, sir.
And alternative is mu1 is not equal to mu2. So since this value is greater than 0.05, therefore we fail to reject the null hypothesis. So that's when we are saying that mu1 is equal to mu2. And let me show you. We have generated normal distribution data with mean 2.001 and the second mean is 2.002. So both of them are not different. See, the difference is I think fifth place of decimal, right?
Yes,
So
sir.
both the groups are not different. Just suppose if we change this now, let me change this. Instead of 2, I have changed the value 3. Now this value is 0.0045. इसका मतलब again mean there is no homogeneity among the variances. ठीक है?
Yes, sir.
Variances equal नहीं है. And then we run this test. It is still saying but the value is less, 0.058. So पहले क्या था, 0.63 something था ना. 0.6.
Yes, sir.
Now
0.6.
0.6 था. Now this becomes too small and it is 0.058. Mean this becomes weak. Though it is, we are saying that difference between two is not significant, but this becomes big. And if we just increase it by a little bit, mean 3.5, say 3.5, and now we see this value. So one value is 2, second value is 3.5. Then we see that it is showing that the the difference between two is significant. Okay. Now we will use pair t test. पेयर टी टेस्ट के लिए मैंने बोला है कि आपको मीन जब भी डेटा होगा तो बिफोर एंड आफ्टर डेटा होगा. जस्ट सपोज वी आर टीचिंग स्टूडेंट्स एंड अर्लियर दे वर नॉट मॉनिटर्ड. ठीक है, यहाँ पे जो एग्जाम्पल डिस्कस है वो दूसरा एग्जाम्पल था, उसको मैंने हटा दिया है, चेंज कर दिया है. ये नाउ दिस इज द एग्जाम्पल ऑफ दिस इज द एग्जाम्पल ऑफ स्टूडेंट्स. पहले उनको जस्ट टीचिंग की गई, देन एग्जाम्स वर टेकन एंड देन उनको फिर क्या नाम है रिपोर्ट किया गया, उनके पेरेंट्स का इंटरवेंशंस हुआ एंड आफ्टर इंटरवेंशंस another exam was taken and we have to see the result before and after intervention whether there is any improvement in both or not. So सबसे पहली चीज ये कि here I am using a different method to read a data, and if data is in Excel file and that Excel file is of XLSX in extension, see this one. ठीक है, अगर ये है तो हम इसको यूज करेंगे, राइट. So a new package and that package is already installed in my laptop. So the function to install this is install.packages and then read Excel और इसको रन कर देंगे, ये इंस्टॉल हो जाएगा. And then I have to library this. ओके, नाउ दिस इज इंस्टॉल्ड. जब यहाँ पे ये प्रॉम्प्ट साइन आ जाए इसका मतलब वी आर रेडी टू यूज नेक्स्ट कमांड. जब तक ये चीज नहीं आती है, ठीक है, जब तक ये चीज यहाँ पे नहीं आती है इसका मतलब अभी ये रन कर रहा है. देन वी लाइब्रेरी दिस, मीन वी हैव कॉल्ड दिस पैकेज इनटू आवर एनवायरनमेंट एंड देन वी रीड द डेटा. हियर सी हियर आई हैव गिवन द पाथ. ये डेटा कहीं और है, किसी और जगह पे, हमने इसका पाथ दे दिया है एंड द पाथ ऑफ द डेटा इज डिफाइंड हियर. पाथ ऑफ द डेटा यहां तक है and then we have written the name of the data and with its extension. Okay, then the data is read. Now extracting the before and after values from this data set or this data frame and we read this one. Now use t-test. So since this data is before and after, so we are not going to check either variances are equal or not. So we directly run this. And when we run this, we have this value. Pair t-test. See, t value is minus 2.5965. See, we have written here before value. So the average grade of before value is less than the after intervention of their parents, after their parents interventions, right? So ये अगर just suppose if first value is large and second value is small, then we have positive value. If first value is small and second value is large, then we have negative value. So that's why here we have negative value. And the degree of freedom of this is 19. And then p value of this is 0.01772. So this means after interventions, the student's performance has improved significantly. Is that clear?
Yes, sir.
Here we are saying, here we said first null hypothesis that mu1 is equal to mu2. Mean before और आफ्टर की जो कंडीशंस हैं both of them are equal, there is no difference between the two. In an alternative we are saying that mu1 mean the marks before are less than the marks after interventions. Okay, so यहाँ पे since the value is 0.017, so we say that the marks before intervention is less than the marks after intervention. ओके, इसको आप अपने तरीके से अपनी लैंग्वेज में किसी भी तरीके से ऐड कर सकते हो, बट यू हैव टू शो दैट मीन देयर इज सिग्निफिकेंट डिफरेंस बिटवीन द टू, एंड आफ्टर इंटरवेंशंस ऑफ देयर पेरेंट्स द मार्क्स ऑफ स्टूडेंट हैज इंप्रूव्ड सिग्निफिकेंटली. क्लियर?
Yes, sir.
ओके, एंड दिस डेटा इज टेकन फ्रॉम द वीमेन. आई थिंक जो मैंने अभी रिमूव किया था, ये डेटा लिया गया है वीमेंस का. It was published in some journal, so I have taken that data from there. So pre and post दो data है. So we run these two data and we say that we have to check that whether there is any significant difference between the two or not. So this data is about energy taken by women's about pre and post menstrual cycles. Okay, so we check that and we see that there is difference between the two or not. So see, pre word is written first, mean pre variable is written first, and the difference between the value of t is positive, so that's mean pre value is more than the post value, and p value is 0.0000 this, so that's mean this is highly significant. And when our test is highly significant, so it says that mean we reject the null hypothesis, and when we reject the null hypothesis, so that's mean pre and post energy takens are different. So women's are taking more energy in premenstrually than the postmenstrually. Okay, then correlation analysis, we may calculate the correlations from the data set, and then we have to check that whether the correlation is significant or not. So before going ahead, we will check that whether there is any correlation between the males and females height. So if there is any correlation between the two, then we will check that whether the correlation is significant or not. So first we have to calculate the correlation, and for that the function is core. ओके, कोर. एंड देन आप कभी भी देखोगे जब भी कोई फंक्शन आएगा, सो COR, दिस इज नॉट अ फंक्शन. व्हेन आई से फंक्शन, सो फंक्शन मीन दिस ब्रैकेट. सो कोर एंड दिस ब्रैकेट, दिस मीन दिस इज द फंक्शन. So now calculate correlation between males and females height, and see the correlation is 0.553981. So the correlation between males height and females height is 0.553981. And then we test this. So the function for that is core.test. Core.test and female's height and male's height, and then method is equal to Pearson. We run this command and we see p value. So the p value is 0.09, which is greater than 0.05. So that's mean there is no significant difference. So when we say that there is no significant difference, so that's mean this correlation is insignificant. This correlation is not significant. Okay? Are you there? Remember one thing, when you are calculating correlation between two or more variables, then you will see that there is always some correlation. Then you have to check that whether these correlations are significant or not. If these correlations are significant, then you say that there is significant correlation between the two. And if these correlations are insignificant, then you say that there is no significant correlation, because word significant should be there. You cannot say that there is no correlation. because correlation is always there. Whenever you have two variables, you will have correlation. Okay, whether it is weak or strong does not matter, but you will always have correlation. Just suppose we have a data set in this R, name name women, ठीक है. So ये जो data है women का data है. We read this data, and in this data height and weight of the women's are there. So we write women dollar height and then weight is equal to women dollar weight. Okay, we run these two, then we calculate the correlation between these height and weight of these two. So the correlation is 0.9954, and this is obvious. अगर किसी की हाइट बढ़ती है तो उसका वेट बढ़ता है ना. This is obvious. So now we will
Yes, sir.
we will check that whether this correlation is significant or not. So we will write height comma weight comma method is equal to Pearson. Spelling. Okay, see here I have written Pearson by small capital P, and this is resulting an error, and it is suggesting that Pearson should be with a small one. So we write Pearson. Okay, so see the p value, and the p value is very small. Okay, the p value is very small, so that's mean this is highly significant. So the correlation between height and weight of females or women's are highly significant. Clear? Then chi-square test for independence. We will be checking that whether they are significantly dependent or independent. So यहाँ पे हमने एक डेटा लिया है. That data is of 13 house tasks and their distribution in the couple. ठीक है, 13 हाउस टास्क लिए गए हैं या हाउस होल्ड कोर्स लिए गए हैं, और ये आपके लिए नहीं है, ये थोड़ा एडवांस लेवल की चीज है, लेकिन हम इसको बना करके समझा देते हैं आपको. व्हाट इज दिस? ओके, सी ये नॉर्मली आप लोग समझते होंगे. इसका मतलब जिस जो बिगर है उसका मतलब वो लोग ज्यादा काम कर रहे हैं. सो बिफोर द वाइफ, ये वाइफ है. लॉन्ड्री मीन दिस जॉब इज डन बाय वाइफ. अल्टरनेटिंग में हस्बैंड ने कभी कर दिया कभी नहीं किया, सो दिस इज स्मॉल, एंड हस्बैंड का जब नाम आ रहा है सो दिस इज देयर इज वेरी स्मॉल डॉट. इसका मतलब हस्बैंड बहुत कम लॉन्ड्री करते हैं. देन मेन मील, कुकिंग कौन करता है? कुकिंग मोस्ट ऑफ देम वाइफ्स आर कुकिंग. देन डिनर, ब्रेकफास्ट, टाइडिंग, डिशेस, शॉपिंग, ये सारी चीजें आ रही हैं. और अगर हस्बैंड के कॉलम में देखें सो वी सी दैट रिपेयर्स आर डन बाय husbands. Then insurance. Basically this data is hypothetical. So ये जो values मतलब कुछ correlated है कुछ नहीं है, ये ऐसे ही हैं, बट ये दिखाने की कोशिश की गई है कि कौन सी चीज किस में आ रहा है. हॉलीडेज जो है तो ज्वाइंटली करते हैं. इंश्योरेंस दोनों ज्वाइंटली हैं. फाइनेंसेस दोनों ज्वाइंटली देख रहे हैं, बिकॉज बोथ ऑफ देम आर वर्किंग, एंड दिस डेटा इज आई थिंक मेड इन some western country. Then this is a matrix, or this is in the form of this. See the data set before going ahead. On one we have wife, alternating, husband and jointly, and other the name of the task, household task, house task. Okay, then we इसको run this by chi-sq in chi-square dot test. Chi-square dot test, this is the function, and simply supply the household. Okay, then write chi-sq. This is the p value, this is the p value. So p value is very small, P value is very small. So when P value is small, so that's mean our test is significant or highly significant. And when our test is highly significant, so what to say? What to say? Anyone from the group?
That
Are you
means we
people there?
reject the null hypothesis.
We reject the null hypothesis. When we reject the null hypothesis, so that's mean house tasks
Test is
are not
significant.
independent. House tasks are not independent. They are dependent either on husband or wife. Okay, they are not independent. और ये हम देखते हैं सब लोग. ये तो बहुत ही कॉमन सी चीज है दैट वी सी दैट वर्क्स आर असाइन्ड दैट हुज ड्यूटी इज दिस. कौन से काम हस्बैंड को करने हैं, कौन से काम वाइफ को करने हैं, दे आर असाइन्ड. सेकेंड, ये एक डेटा लिया गया है. दिस डेटा इज टेकन फ्रॉम द हैबिट्स ऑफ द पेरेंट्स एंड वी आर चेकिंग दैट वेदर दे आर ट्रांसफर्ड टू देयर चिल्ड्रंस और नॉट. सो ये मीन सीट्स बकल्ड अनबकल्ड का है. तो जितने पेरेंट्स ने बकल्ड किए थे और जो उनके चिल्ड्रन ने बकल्ड और अनबकल्ड किए हैं, उस चीज को देखा गया है कि मीन जितने पेरेंट्स ड्यूरिंग ड्राइविंग सीट बेल्ट लगाते हैं और जो बच्चे लगाते हैं, उस डेटा को चेक किया गया. ठीक है, से दिस ये डेटा है. अब इस पे हमें चेक करना है कि ये क्या, ये जो हैबिट है पेरेंट्स का और चिल्ड्रन का, ये डिपेंडेंट है और इंडिपेंडेंट है. सो आप लोग ऐसे बताओ, वाइल्ड गेस क्या आना चाहिए? डिपेंडेंट होना चाहिए, इंडिपेंडेंट होना चाहिए?
Dependent.
डिपेंडेंट. इट इज सेइंग इंडिपेंडेंट या डिपेंडेंट, क्या कह रहा है? ऑन द बेसिस ऑफ दिस पी वैल्यू. आप लोग नीचे पढ़ लेंगे. आई थिंक आप अकेले ही रिस्पॉन्ड कर रहे हैं, बाकी नन of the participant is responding. So whether they are present or not. See, our null hypothesis, the children's or child's habit is independent from the parent's habit. Alternative is the child's habit is dependent on the parent's habit. Since the p-value is less than 0.05, so that's mean we reject the null hypothesis. When we reject the null hypothesis, so that's mean we are saying that the child's habit is dependent on parents' habit. So अगर parents बकल करेंगे, parents कोई काम खुद करेंगे तो बच्चे उनको फॉलो करेंगे, उनके सिर्फ स्टेटमेंट देने से वो नहीं मानेंगे. एक और बहुत सारे एग्जांपल हैं, लेकिन अब इसको मैं छोड़ रहा हूं. एक चीज दिखा दूं कि आपको मैट्रिक्स कैसे करना है. सी वी हैव डिस्कस्ड अबाउट द मैट्रिक्स एम. मैट्रिक्स एम, अच्छा आज नहीं किया, कल किया था. डे 1. नहीं है, चलिए लीव करते हैं इसको, क्योंकि उस पर जाएंगे तो वे टाइम फिर हमारे साथ, वी आर शॉर्ट इन टाइम. देन वी हैव टू टेस्ट ANOVA. वी हैव टू यूज ANOVA टेस्ट. One ANOVA test mean one way and two way ANOVA. Okay. So one way and two way ANOVA में mean एक तो ये डेटा है, दूसरा हम एक डेटा और कर लेते हैं, इसको बाद में फिर हम करेंगे. हम उसको पहले कर चुके हैं. In data is equal to chick weights. Okay. So in this we have names of this data set is to mean weight and feed. Okay, so we print feed to see that whether this is mean the, to check this thing structure, structure is there, and this will show us the types of data. This is the name of the data, mean variable, name of the variable, weight and feed. Then after column, this is numeric, and this one, second one is factor. सो हमें चेक करना है कि हमने 6 टाइप के फीड्स दिए हैं। 6 टाइप के फीड्स देने पे क्या उनके बीच में फीड्स देने से वेट गेन डिफरेंट है या सेम है। सो हमारा जो यहाँ पे नल हाइपोथेसिस होगा, दैट नल हाइपोथेसिस that all of the feed types are contributing equally। इसका मतलब यह है कि आप कोई भी लो, चाहे केसिन दो, हॉर्स बीन दो, मीट मील, सोयाबीन, XYZ जितने भी आप मील दे रहे हो, सबसे इक्वल वेट बढ़ रहा है। ठीक है, किसी से ज्यादा वेट नहीं बढ़ रहा है। और अल्टरनेटिव क्या होगा, एट लीस्ट वन ऑफ द फीड फैक्टर इज डिफरेंट फ्रॉम द अदर्स। क्लियर। नल हाइपोथेसिस में क्या होगा कि सारे के सारे इक्वल हैं, सारे के सारे क्या हैं, इक्वल हैं। और अल्टरनेटिव में होगा कि कम से कम एक ऐसा है जो इक्वल नहीं है, वो डिफरेंट है। ओके, सो यहां पे हम सेट करेंगे m is equal to the function is AOV। ओके, AOV लिख दिया। अब यहां पे देखें, जो न्यूमरेटर या न्यूमरिक वेक्टर होगा उसको सबसे पहले यहां लिखा जाता है। सो राइट, VEIGHT वेट, एंड देन फंक्शन इज टिल्ड। इसको आप स्टार के साथ में और स्केप के नीचे 1 के बगल में होता है ये। ठीक है, 1 2 3 4 5 होता है, तो 1 के लेफ्ट साइड में होता है ये। शिफ्ट एंड देन दैट बटन विल गिव यू दिस। ओके, एंड देन वी राइट फीड, इसका कंपैरिजन करेगा, इस फीड का ये कंपैरिजन करेगा। सो देन राइट फीड एंड देन फर्दर कॉमा डेटा इज इक्वल टू chick weights। okay, now run this and then we summary this model। m chick। okay, so first say feed is there are 6 types of feed and 6 minus 1 is the degree of freedom, and residual is 65। I think 70 observations, and that's why this is 65। and sum of square, then mean sum of square, this is sum of square। सम ऑफ स्क्वायर यहां लिखा हुआ है, सो सम ऑफ स्क्वायर ड्यू टू फीड एंड सम ऑफ स्क्वायर ड्यू टू रेसिडुअल, ये अलग अलग नंबर्स हो गए। देन मीन स्क्वायर ड्यू टू फीड एंड मीन स्क्वायर ड्यू टू रेसिडुअल, देन एफ वैल्यू एंड देन दिस इज पी वैल्यू। ये जो यहां पे लिखा हुआ ना, प्रोबेबिलिटी ग्रेटर देन एफ, सो दिस इज एक्चुअली पी वैल्यू। ओके, this last column is p value, and see our p value is 0.00000। after a long time we have 594, so that's mean this value is less than 0.05। so when this value is less than 0.05, so what to say,
Less significant.
no,
Insignificant.
no,
We will reject the null hypothesis.
yes, the p value is less than 0.05, then we reject the null hypothesis। okay, so that's mean at least one of the feed factor is different from the others। okay, so जब ये चीज हो गया, then we want to know that which factor is different from the others, we want to know this, and to know this we have a post hoc test, and that post hoc test is named as Tukey। so Tukey is equal to Tukey HSD, the function is Tukey HSD, and we give the name of the fitted model m chick। see, there are combinations and you have to focus on this only, mean last column, just focus on last column। ठीक है, सो लास्ट कॉलम में आपको 0 नजर आएगा, 3 नजर आएगा, 9 नजर आएगा, बहुत सारी वैल्यूज नजर आ रही। सी, दिस इज 0, सो दैट्स मीन हॉर्स बीन और केसीन ये दोनों डिफरेंट हैं, ये दोनों इक्वल नहीं है। ठीक है, ये लिंसीड एंड केसीन बोथ ऑफ देम आर डिफरेंट। both of them are not equal, but casein and meat meal, the value of this is 0.33, so that's mean they are same, ये different नहीं है। तो इसी तरीके से आप सबको चेक कर लोगे और यहां से आपको वैल्यूज मिल जाएंगी, आपको समझ में आ जाएगा कितनी वैल्यूज अलग हैं, कितनी वैल्यूज अलग नहीं है। इसको हम प्लॉट के जरिए भी देख सकते हैं, वी कैन चेक दिस बाय प्लॉट। सो व्हेन वी प्लॉट, वी सी ये जो जीरो की लाइन है, इस जीरो की लाइन से जितने कट हो रहे हैं वो सारे के सारे इनसिग्निफिकेंट हैं, और जो ये दूर हैं, जितने ज्यादा दूर हैं वो उतने
उतने
ज्यादा सिग्निफिकेंट।
सिग्निफिकेंट है।
हेलो, जितने ज्यादा दूर हैं उतने ज्यादा
सिग्निफिकेंट है सर।
सिग्निफिकेंट। ओके ओके, मैं मुझे समझ नहीं आया था, मैंने लगा शायद कुछ बाय मिस्टेक आवाज आई है। 1 मिनट, द लैपटॉप इज ब्लैंक। Okay, so this is the explanation of analysis of variance for one way ANOVA। और इसी तरीके का टू वे ANOVA का भी कर लेते हैं। टू वे ANOVA, सो यहाँ पे सिर्फ एक फैक्टर था, फीड फैक्टर था। हम एक टूथ ग्रोथ डेटा है, टूथ ग्रोथ डेटा ऑफ पिग्स है, और उसको दो तरह के जूस और वो दिए गए हैं, उनका डेवलपमेंट देखा गया है, उनको अलग अलग लेवल की विटामिन दी गई हैं। सो वी चेक दिस वन एंड देन वी राइट स्ट्रक्चर। स्ट्रक्चर से STR इज यूज फॉर स्ट्रक्चर, और यहां से हमें डेटा नजर आ जाएगा कि डेटा का स्ट्रक्चर क्या है। सी, this is of data dot frame, the data types is data dot frame, 60 observations on 3 variables is there। ठीक है, first one is len, len mean length of the tooth, it is a numeric vector। ठीक है, और इसकी वैल्यूज आगे गिवन है कि किसके कितने हैं। देन दूसरा इज SUPP, आई थिंक ये सपोर्ट या समथिंग कुछ करके है, जो जूस दिया गया है इसको, और वो दिस इज अ फैक्टर वेक्टर्स, फैक्टर वेक्टर, और फैक्टर वेक्टर में 2 लेवल्स हैं, दिस इज द लेवल्स OJ एंड VC। और जो डोज है, डोज भी एक्चुअली ये फैक्टर है, लेकिन यहाँ पे जो कि 0.5, 1 और 2 mg दिया गया है। सी दिस 0.5, 1 एंड 2 mg पर डे। सो 3 अलग अलग ग्रुप बनाए गए हैं। तो एक्चुअली दिस शुड बी आल्सो अ फैक्टर वेक्टर, लेकिन ये यहाँ पे फैक्टर वेक्टर में इंस्टॉल नहीं किया गया है, इसके अंदर बाय डिफॉल्ट नहीं है। सो वी हैव दिस फंक्शन। आई थिंक अगर आप आर जानते हैं तो थोड़ा आसान होगा, अदरवाइज थोड़ा सा ये मुश्किल होगा कि इसको कैसे कन्वर्ट किया जा रहा फैक्टर में। सो वी हैव गिवन द नेम tooth growth, name of the data set, then we are writing dollar। so dollar mean we are extracting the data and that is called dose। dose को हमने extract कर लिया, and then there is a function as dot factor। so as dot factor का मतलब change this data into a factor and then giving again x is equal to tooth grows dollar dose। okay, so after this we have converted our dose into factors, and then we again use structure function to check this। so first one is length, and second one is factor, and third one is also factor। so see, our dose is converted into factors, and this factor contains 3 levels, 0.5, 1 and 2। okay, क्लियर? सो ये थोड़ा सा है, ट्रिक है, ये बेसिक लेवल से थोड़ा सा एडवांस है, बट इफ यू ट्राई देन यू विल लर्न। देन we have only one, we have to see the 2 factors effect on the length of tooth or teeth। so we fit 2-way ANOVA। so length, see this is first variable length, numeric vector is written first, then tilde, this sign is used, is tilde, and I have told you that how to make this, and then sub and plus dose, right, and then data is equal to tooth growth। कभी हम डेटा इज इक्वल टू लिखते हैं, कभी नहीं लिखते हैं, डज नॉट मैटर, but data is equal to tooth growth. And then we run this. And then we write the summary of this. And summary of this is saying that sub mean VC और OJ जो दो तरह के विटामिन दिए जा रहे थे इसको, जो ascorbic acid, one is orange juice is used for OJ, and ascorbic acid it is used for VC, and both of them are the source of vitamin C. Okay, और जो इनके लेवल्स थे that were 0.5 mg per day, 1 mg per day and 2 mg per day. सो जूस टाइप जो है वो दो तरह के हैं, या विटामिन सी के जो लेवल्स हैं वो तीन तरह के हैं, और विटामिन सी के जो सोर्स हैं वो दो तरह के हैं. सो फर्स्ट वी सी द सोर्स ऑफ विटामिन सी, दैट इज सब. सो वी सी देयर इज अ सिग्निफिकेंट डिफरेंस because the p value of this is 0.000429. इसका मतलब क्या हो गया कि इन दोनों में हाई मतलब ह्यूज डिफरेंस है. So orange juice and ascorbic acid, both of them are not equally contributing to the growth of teeth. They are unequal. And second, we see the dose. So for dose, we have p value is this. इसकी p value बहुत small है, that is 0.000002. Okay, and that value is still less than this. So that's mean the doses are also not significant. The doses are also significant. They are significantly differ. 0.5, 1 and 2 सब एक दूसरे से significantly differ कर रहे हैं. Now we will use post hoc test, and that is Tukey HST. The function for this is Tukey HST, and then given the name of the model, that is two-way ANOVA. Then we run this, and from here we say that इसने सिर्फ हमें इसका वैल्यू दिया है, सब वाली वैल्यू को इसने बोला है that VC, OJ and C both of them are again different. यहाँ पे ये बता रहा है हमें, and then this, see the p value of all. So 1 to 0.5, 2 to 0.5 and 2 to 1, all of the doses are different from each other. Okay, all of the doses are different from each other. Now we plot them two-way Tukey and see this. First we have this plot. This is between VC and OJ. So VC and OJ में देखें यहाँ पे इस लाइन पे कहीं पे भी जीरो नहीं है, राइट? ये जो लाइन है -5, -4, -3, -2, but there is no zero. So zero नहीं है, that's mean this difference is significant. And then we have another for dose, and here there is no 0 2, 5, 10, 15. अगर जीरो की लाइन इसको कट नहीं कर रही है तो इसका मतलब क्या है? They are highly significant. So this is up from my side. If you have any question, you may ask. Hello.
Yes, sir. Yes, sir.
Sorry.
No.
You are not audible.
No, sir, we don't have any doubts. Thank you so much.
Okay. Anyone else?
No, sir.
Okay.
Clear.
Okay, sir. So they don't have any. You may conclude.
Okay. Okay. Thank you, everyone. And thank you,
Thank you, sir.
Ahmedur Rahman, sir.
You're welcome, sir.
I request all participants kindly give your feedback here. We are waiting your feedback. The most of the people's not giving the review on this link. Please review on this link. Okay. How many people review on this?
Yes, sir.
You have to done.
Yes, sir. I'm giving the review, sir.
जिन लोगों ने नहीं दिया है वो लोग थोड़ा सा कर दे प्लीज हैं. उसके बाद we will provide the certificate tomorrow or after tomorrow. Okay? पुलोमा भी कह रही है दीदी का.
Sir.
Okay ना? Okay, I think it is okay. So see you. If you have any doubts, you can ask in the WhatsApp group. There will be the WhatsApp group. Whenever you are practical, आपको कुछ समझ नहीं आता है, कोई प्रॉब्लम होती है, तो ये can do. तो I think provide the record videos. हाँ, Paloma, I will provide you. I will provide you. ओके ओके ओके. हाँ ठीक है, मैं आपको प्रोवाइड कर दूंगा. आज का वीडियो तो डाल दिया है, कल का तो डाल दिया है, और आज का भी वी विल सेंड इन द ग्रुप, है ना. तो ओके, आई थिंक ओके. ओके, थैंक यू वेरी मच एवरीवन, एंड थैंक यू अहमद अहमद सर. थैंक यू
You're welcome, sir.
एवरीवन फॉर द
Welcome.
दिस वंडरफुल सेशंस. रियली उम्मीद है कि आप लोगों ने बहुत कुछ सीखा होगा आर के बारे में. आर इज़ द वेरी इंपॉर्टेंट टूल्स फॉर द डेटा एनालिसिस. तो we will see you the next any other program. तो thank you very much everyone. Of if you want to say something, जो भी आप लोग कोई है, अगर आप चाहते हैं, if you want to say something, if you want to give your feedback on the camera, so you can open your camera, you can say and you can express your views. है कोई है ऐसा जो कुछ कहना चाहता है? If you want to do something, I think the Priyanka was the very active in the whole session. Priyanka, you want to say something?
Sir, actually, I just want to say yesterday I was not able to digest this all statistics, but today I was kind of interested in the session. That's why I understood many things. So I am totally happy with the session. Thank you so much.
I think yesterday it was basics, and most of the people don't like basics, so that's why I think you were not getting the things.
Sir, actually, I am a student of life sciences and I don't have any kind of link with this subject. That's why I was unable to understand at starting.
Okay.
That's why.
So in future we might be doing other workshops too. So if you are interested, then you may join and learn many more things. And if you still have problems, then you may contact to sir. I mean, and to me too, as per your convenience. Okay.
Yes, sir,
Okay.
definitely. Thank you so much.
Welcome.
Okay, I think thank you very much everyone. Actually, we have another sessions on Qboard. Okay, thank you very much everyone, and see you the next time. Okay, thank you,
Thank you,
sir.
sir.
Thank you,
Thank you, thank
Indrajit,
you, thank you, sir.
Roma, and Bhavishya, Jarlimon, and Priyanka and Sanjay Khan. Okay, thank you very much everyone.
They are there.